Hello and welcome. Today we're going to look at a demo in regards to IBM MQ and GitOps. Our setup is a config repo being GitHub. We're going to look at Argo and IBM MQ clusters. So the demo steps are A. We're going to take a look at the config repo being GitHub. We're going to look at an existing install that has been provisioned. We're going to look into it with MQ console and Red Hat OpenShift GUIs. Then we're going to install a complete new IBM MQ cluster using the config repo, Argo, and eventually we're going to provision it into an MQ cluster. So, first, let's take a look at GitHub and what we have in there. In here, if we click ourselves down into the right project and into the right folders, we have a so-called Argo application and all its configuration. In here, we have the configuration for IBM MQ. In the so-called config map, we can configure, in this case, an IBM MQ queue, for example. And in the configuration for IBM MQ, the cluster, we give it a name. And we configure it to be Native HA in this case. So here we're logging into IBM Cloud Pak for integration, and we're going to drill ourselves down into the MQ that has already been provisioned, the Queue Manager Alpha in this case. So within Cloud Pak for integration, you can reach all the different IBM products, but in here we're looking at the Queue Manager Alpha, and the queue, if you remember it, was alpha.q1. So that has been configured in GitHub, provisioned by Argo, and provisioned in MQ. Now we're logged into the OpenShift Kubernetes UI, and here we're just clicking ourselves down into the pods, and I'm going to filter out the pods we're interested in. If you remember the name Alpha, we can see three different pods, or three different processes, if you will, of MQ servers. The different queue managers, one is active. If you see 1/1 there, that's the one doing all the heavy lifting when it comes to traffic. So we can simulate a crash of the active MQ server. So we can simply delete the pod from here. So what happens then? If we delete it, pay close attention. Terminating, this will be fast. Failover, boom. It failed over to Queue Manager Alpha IBM MQ-0 in this case. That's how fast it will fail over if you have native HA with IBM MQ. So I speed the clip up a bit here. A new MQ server is coming back up, but it will take like a minute or two. So when that is up and running, the state is the same as before. The only difference is that we have one new active MQ server. So let's do everything from scratch. Let's create a new install of IBM MQ. But first, let's take a look into Argo and the role that plays. Argo is installed inside OpenShift or in your Kubernetes environment. So first off, let's log in. And the role of Argo, of course, is to sync everything that you've configured in GitHub in this case. And it will use that to provision things in OpenShift. So here we're clicking ourselves down into the Argo application, and the Argo application is responsible for all the different MQ clusters in this case. Here we can see the connection straight into GitHub. So that's where it's getting its configuration for everything. Here we see different clusters. We have 4 clusters in this case: Alpha, Beta, Delta, and Gamma. But let's create a new MQ cluster. And we can do that by going into the alpha configuration and using that as the base. So we're just taking that text and changing it locally on my workstation here. So I'm adding a couple of more queues into this specific config map, which will have a new name, and I will refer it in this file. But in here I will change the names of the MQ servers. It's still native HA because I want to have that failover possibility. But I'm renaming everything to my own. So then I go to GitHub and create these new configurations. So my own config map for my new MQ cluster. And I also create the actual file for the MQ cluster. So everything has been renamed to my own basically. But I used the alpha configuration as a base, so I don't have to reinvent everything. So now I have my new cluster config, and the cluster config is referencing my new config with my queues. So Argo CD detects the changes and provisions this immediately. So if I go down in my Argo application again, I've filtered on queue managers. I can see my own queue manager now. So now instead of 4, I have 5 clusters, all being provisioned under the Argo application. So I remove the filter here, so you can see all the different configuration that is being provisioned and all the different artifacts Argo CD is handling from the GitOps repository. So it's a lot of things, everything from disk to configuration. Argo has a lot of nice features. You can see how traffic moves from one place to another between different components and different pods, for example. Here we can see the actual servers, or the different worker nodes as it's called in Kubernetes. We can see our pods in there, my own MQ-0 being active. Quickly we move into the GUI for IBM MQ specifically within IBM Cloud Pak for integration. And here we can see that we've provisioned our new MQ cluster. So if we go in and check out the queues in my own queue manager, we can see that we created 4 different queues here. And we will validate, send a test message, and that's the end of the demo. So thanks a lot for your time, and I hope you found this interesting and realized that GitOps can be a good way to provision your MQ clusters.